hopefully right now, what the heck's that? Okay. Are you looking right now at our Canvas page? Okay, great. So let's go in student view, just clean it up a little bit. There we go. So this is something that you've got. So let me show you what we have in Canvas. A lot of the information is Canvas, and the stuff you need to do is in WebAssign. Roughly that's the split. So if you click on this top one, if these ones tell you a little bit about myself, and then they tell you about joining WebAssign if you haven't done WebAssign before. This one here is a major one, although it's kind of empty right now. It will eventually fill up. There's our link. That'll work for about 4 weeks, then I'll have to redo it. And here you're going to find all the lectures that we do over the next 10 or so weeks. So if you click on week 1, you'll see it's blank right now, but I'll be putting today's video here, with probably the exception of the really bad jokes, because Sally's trying to take my title of worst joke teller in the class. So that one there is what we've got. That results in that. In fact, go back a little bit. If we go on, there's the office hour link. There's in more detail how to join WebAssign. There's a Zoom page. How to use Microsoft Lens, some useful websites, a little page for fun, and what the heck is this? I forgot what this is. Oh, it's a WebAssign link to the same kind of information. So I'm assuming how to join WebAssign. It's just get more up-to-date information. So you might use that if my version doesn't work. And that's basically what that contains. Now, class resources you can look at yourself. It tells you all sorts of things like if you don't have equipment, you can get borrower, off the college. But if you go to class resources, what we have here are a whole load of stuff that you might want to use. For instance, chapter 14. Click on that. And if you want to see some videos on partial derivatives, I have some videos. There we go. On partial derivatives. And these are, mostly these are from YouTube, but I picked them because I like them. And I think it's good to see how other people phrase things and do things, because it gives you a better, a wider way of looking at things, I guess, a better way. And there's some PDFs of various helps. For instance, randomly, if I click on this one, it's a solution to one of the homework questions from 16.7. So at the bottom here, we have all sorts of, this one does vector fields in 2 and 3D. This one does contour plots, contour maps. They're the same thing, but 2 versions. And there's 3D graphing. Because some of the stuff is visual and you want to use it to see visually what a surface would look like. Let me click on that at random. Who knows what it's got set up of anything. Right, so I think I can do it as z equals x squared minus y cubed. There we go. So, oops, not that way. Although that's interesting in itself. There we go. And what you've got here is the surface of that particular 3D function. It's pretty boring, that one. It's really just a saddle point. But it's cool. Things to do. Okay, and that is the end of those. So there's tons of stuff in there for, it's up to you what you want to do, what you want to use, but it's there at least. So let's look at the syllabus. And everybody knows this, except if you've never had me before. Contact me only through my email address. When you go into WebAssign, it has links that says ask the professor or ask for extensions. I never see those darn things. Just send me an email with a question, or send me an email if you need to get an extension on your homework. Here's our Zoom office link. prerequisites, which is essentially 163, 2.0 or better. Equipment that you need. There's a place you can get the loaners. WebAssign has the ebook, so you don't need to physically buy a textbook unless you're old school like me and kind of like paper in front of me. Here is essentially information about joining WebAssign. I've got a much more in-detailed version of that in Canvas, so I would probably use that. The only 2 days that we have that I believe are holidays, Martin Luther King on Monday the 7th and President's Day, Monday the 21st. So those 2 days there won't be classes. The structure, well, this bit is very familiar. If you've had me before with a little extra, there is a difference now. Broken into weeks, there's week 1, week 2, there's week 10. Technically, week 11 is the finals, but Monday is a class day, so I'm just doing that as a review for the final day. And our final is on Thursday, 10 till 1. If we now scroll back to week 1, we're going to be doing 4.3 and 4.5 this week, and this is the new guy. There are going to be 10 online tests, and they'll be in Canvas. And you'll see what percentage they're worth later. But essentially, you won't see them on WebAssign until Saturday morning. And you've got from any time in Saturday morning all the way up to what, 9 o'clock on Sunday to do it. Whenever you click on it, you've got 90 minutes. A clock starts ticking and then it's gone. Tim, question.
So it's not like before where there were 3 tests and you dropped the lowest one. There's 10 tests and you're dropping the lowest one?
Dropping the lowest 2.
Oh, you give us an extra. Thank you.
Percentage wise, it's actually less than the other version, but it sounds more.
No, I can tell it's less because it's 20% instead of 33%. But
right. But there are some differences. The ones you're talking about were in class and I saw you. These ones are really much more like homework. You're doing them, you know, 3 p.m. on a Sunday, 90 minutes. So the minute you kick in, you've got 90 minutes to do it. So do not go near it until you're ready, right? Because time will zoom by like nobody's business. It's also going to be, oh, shush, that's my dogs arguing. They're also going to be 5. You can have 5 choices to your answer, but it won't tell you you're right. So whatever one you pick is the last one. So the one that you want to be the answer I need to see, make sure it's the last one before you submit. You also don't need to upload working for it or anything like that. It's much more like a homework, right? You do it and you get it right or you get it wrong. Now I will look at them and I will make alterations. You know how sometimes WebAssign can be really pernickety, like you need a comma between some things and if you don't, it's wrong. Or you write 2 quarters and it wanted a half. And, you know, I'll fix those things. But apart from that, it's right or wrong and you'll get your points that way. So that's what your tests are going to look like. What we're going to have instead then, if I can find it, here we go, is a midterm. And the midterm is going to be like your final, where you turn up in a Zoom and I look at you and you upload your working into Canvas and all that good stuff. So there'll be one midterm and of course a final. Now, this bit here is basically telling you what Calc 4 is about. If Calc 3 was a mishmash of all sorts of stuff, Calc 4 isn't. Calc 4 is essentially the calculus of multivariable functions. How to differentiate, how to integrate, and what can you do? And it's pretty big stuff because we're going to deal with curls and divs, which evidently anybody who works in electronics and motors and things going inside motors and coming back out and magnets and you name it, that's what their bread and butter is. They look at things called curls and divs. These are just calculus in multivariate functions, and we'll show you how to essentially calculate them. I won't be spending any time on applications, or very little time, I should say, because that's really not what my job is. I'm not taking over an engineer class. I'd be horrible at it anyway if I tried to. But we will give you the math to be able to do it, right? So once you know how to calculate divs and curls, we'll also be telling you some very interesting properties about things called conservative fields. And the applications are phenomenal. Just off the top of my head, do you know those little models that they put in wind tunnels and blow smoke over them so you can see the direction they can go? All of that is multivariate function because it's all done in 3D. And what you're trying to model is the pathways and the forces that are acting on that. That would be a vector field. Essentially, the wind is a vector field and the aircraft is a space curve trying to fly through a vector field. So you can actually come up with some quite interesting results. And that particular situation ends up becoming what's called a line integral. So there is tons of stuff. So if you're into the engineering world, you will love that.
If you like
say again?
If you like hydrodynamics at all, Frau tanks and all of Frau's work was all based on this class.
There you go. I don't even know who that guy is, but the good news is I don't need to teach the calculus.
He revolutionized ship design in the late 1800s, early 1900s by making tanks. Maybe it's a little earlier than that. By making tanks that they could put model boats in and see the water.
Oh, I have seen
Frau tanks.
I have seen them on TV. They're quite big versions, and they put tankers in, and then they stack little miniature containers and see how unstable they are if you turn them at 90 degrees to the current and so on. And good ones rock and bad ones keel over. Yeah, I do. I didn't know that's what it was, but I do know of that. Academic honesty is basically don't cheat. If you have any kind of issues, which reminds me, do you want me to put on the, darn it, if I could remember, it's called closed captioning. Does anybody want the closed captioning? Okay, we're good then, just in case it was. Continuing then, let's look at points make prizes. You get 10% for taking part in the class. How do you take part? You will say your last name sometime today. Rosie, for instance, will just say Harper. And Dustin, you'll just say Lopez. And someone has just done it. So Will's got ahead of the game, right? And I just take that off and stick it in a spreadsheet. And I'm getting better at it because the less information, the easier it is for me to work with. So that's it. So if you want to do it right now, that's fine. That's 10% of your grade. So, I mean, if you come every single day that you can, you've already got 10%, right? You still get another 65% to pass, but you've got 10. Homework assignments, 25% of the grade, you know how that works. The 10 online class tests that we talked about, the best 8 get counted, and that will be 20% of your grade. So if you add that to the homework, you see 45% of your grade is going to be in WebAssign, either through homeworks or through the class tests, class quizzes, whatever you want to call them. And then a 30% final and a 15% midterm. So you put all of those together and they should add up, I hope, to 100% or I'm in trouble. And that's where your grade will be. And 75% gets you a 2.0, which means you pass. And anything less than that is not good because it means you have to take the class again and get a 4.0, which will be fun, but very difficult. Okay, here is a link to this class. You used it, you got here. That'll work for about 4 weeks, and there's some more detail about it.
By the way, Professor, you stopped the screen share.
I did? Oh.
Yeah.
I don't remember doing it, but I probably...
It was when you were looking for the closed caption.
Oh, gotcha. Right, can you see it now? No?
We can see it.
See it now. Okay. You can see you, but you can't see grading. This course will be graded. Can you see that page?
We can
We
see
can
it.
see it.
I can see it.
Everything is
Okay.
working optimally.
Perfect. Okay, so you can read this again, right? So you heard what I said, even if you couldn't see it. I don't want to spend too much time. Right, there's our link to this class, and there's more detail on each of the things we talked about. There is some extra credit. Every homework that you do without asking for an extension will get you 0.25%, and that adds up to 2.5% if you don't ask for anything. And that'll be added onto your grade as extra credit. Then you get your percentage, and after that, you know, 2.0 or 4.0, whatever you're looking for. Usual places, it does get harder the further up the food chain you go. So if you are talking about, let's leave this for a minute. If you were talking about Calc 4, the number of people who can actually help you with Calc 4 is quite limited, right? I know they do an online tutoring, so hopefully there's some decent people there. Very often, yourselves are the best resource. So Rosie, when she gets stuck, will send an email to Brendan saying, how do you do question 4? And Brendan will say, I don't know, but I'm going to ask Will for you, right? Or he might say, oh, you've put your thumbs up. He might say, yes, I do know, right? Office hours are 10 o'clock. Because of my schedule, I'll be able to start this class a little bit early, so you can catch me before the class if that works better for you. I won't be able to help you at the end really, unless it's a 30-second thing, because I've got a class right after this, so I don't have that. Look at those videos, look at the PDFs that I put in Canvas, there's resources for you as well. Send me an email and, you know, I'll try and help you that way.
So,
Yes, Ella.
Since you're saying send you an email, would that be through your student email, through my student email, or would the Canvas messages,
It doesn't matter. Both of those will get to me. Don't use WebAssign's feature where it says ask your professor. Those things, I don't know where they go, but I never get them. Right. So email me as drobertson@olympic.edu, or just use a Canvas thing. That works perfectly. Either one will do. Any other questions about the syllabus? Because I want to go to WebAssign and then call it good, and we can get started on the fun stuff. Right. You can read it, you know, and maybe ask me tomorrow if you're not sure. Okay, let's move on then. And I'm just getting the thing set up. Here we go. We'll do it on student view. That might make more sense. Right, so this is what WebAssign looks, right? Sunday midnight is the drop dead date for homework, unless you ask for an extension. That one there should be a baby one, but I put it in because some of you may not, it's unlikely, but may not have done WebAssign at all yet. And that just takes you through it. It takes you about 15 minutes, so it won't slow you down much, but you should still do it because it's part of your course. Midnight Sunday.
That says noon on Sunday.
That does say noon, you're right. I'll fix that. It will be midnight Sunday. 12 p.m. is lunchtime. Okay. I should actually make it 11:55 p.m. because that's sort of 59 p.m. That's easier to not make a mistake. But a little note to self. Okay, I got that then. I'll fix it sometime today. Now, you look at the questions. And that's basically it. This first section is partial derivatives. And a lot of it we have touched on, but this is also added to it. So I've put some other things that you haven't seen yet. And that's basically WebAssign's homework. You just click on it and you write your answer in and you get stuck on it. You can ask for what can you do? Is there a hint box in some questions, or give me another one like it kind of thing? that the usual they do?
I think it depends on settings, but sometimes questions can have a practice another.
Right, practice another. Right. I pretty much have set it up, I think, for all of those features, so you should get it. Right, let's get started on, will you be quiet, young lady? They're both trying to share one place, his place. Oh, bugger. Yes, you. Shush. Oh, you can't fall out with something as cute as that. She's a right pain in the butt, but you can't fall out with them. Right. Okay, guys, let's, oops, papery, move around. Let's remind you of partial derivatives. Here are some examples I'll be doing in a few minutes, but let's do a bigger picture thing. If you take a function, a multi-variable function, and it's written down, say, like this notation here, we can differentiate it. But the problem that we've got is that there are two distinct variables. X and Y are both variables, right? One's not more or less important than the other. So when you think about derivatives, you actually have two derivatives to think about. There's the derivative of the function with respect to X, and we call that the partial derivative with respect to X. But you've also got the partial derivative with respect to Y. And other notation, which I actually prefer, is to write that down, right? Now, the technique for finding partial derivatives is, imagine that this guy is the only variable, in this case X, and any other letter of the alphabet, treat it as a constant, treat it like it was a number. So derivative of X squared with respect to X is 2X. But what about the derivative of Y cubed with respect to X?
0.
It's 0. Now, typically I won't write 0, but I'll put it in today. Now, what about XY squared? What did you get if you differentiate that guy with respect to X?
That would just be Y squared.
So in this case, the answer is 2X plus Y squared. Does that ring some bells? Yeah, I remember doing that. It's a nice, easy one to get started.
Yeah.
Now, if you do it now with respect to Y, X squared gets you nothing. The Y cubed is a power rule. And this guy, what would XY squared get you?
That would be 2XY.
And then if we tidy it up a little bit, you have this. Now, it is not that unusual once you've done a few of these, that these two answers are quite distinctly different, aren't they? Right? They're noticeably different. And that is generally a truism, that for almost every situation, there are always exceptions to everything. But aren't those two things very rarely ever equal to each other? Now, you can, and you do have some other questions involving first partial derivatives. For instance, I might not ask you that, but ask you that. Now, what this notation is saying is find the partial derivative of that. Actually, it's probably more like that, but it's the same thing, right? It's asking you to find the partial derivative of f with respect to x and then evaluate it at this one particular point. Now, the convention is x goes there and y goes there. Now, we already know that the answer in a general format is this guy. But in this case, that becomes 2 lots of 1 plus 2 squared. And that becomes 2 plus 4. And so the answer is 6. So do you see in these questions, and there are homework questions just like this, won't your answer end up being a number of some sort, depending on what x and y happen to be? So far, so good. Now, if you're wanting to try and visualize what on earth say, this thing here is. I mean, what does that number 6 tell me? I want you to imagine that you sketch this fella here. Now, oops, there we go. The only thing I can tell you for sure is that this is a surface, right? It's pretty much all I can tell you. So let's just pretend that it's a surface that looks like this. Right, and I'll put in some kind of curvy lines to try and emphasize the shape, right? Now, can you imagine that at the point 1, 2, which is about here on the floor, if you went up at this point here, right? Can you imagine slicing this shape, right? Vertically, like this. When it meets up with this curve, won't you have a curve that looks something like that? And then the point 1, 2 will meet it about here. And that guy has a slope of 6. So the partial derivative is basically taking the shape and either slicing it parallel to the y-axis, which is what a df by dy does, or slashes it parallel to the x-axis, right, which is what a df by dx does. Now, when you do that slice, don't you just get a single curve? And then whatever 1, 2 happens to be on that curve, right? The slope is what this guy is. So if you're one of these people that kind of needs to know what is that number I've just found, it's a little convoluted, isn't it? There's, you know, it's a little 3D turning into a 2D curve turning into a slope, but that's what it would be. Now you might think, well, how could that be important? Well, can we imagine a different function where this answer was 0? So a different surface, and I found its partial derivative with respect to x, and I found out it was 0. What could that be telling you about the surface?
That it's not, it's flat.
It's flat. Couldn't it be telling you this? That you know that the top of a hill is at 1, 2, right? So the surface has a hill. Now it could also, couldn't it be telling you that that point, because at that point there isn't the tangent 0, horizontal. Couldn't it also be telling you that at that point it's the bottom of a valley, right? And the equivalent to that is, can you remember finding derivatives equal to 0 to find local max and mins? You remember finding f dashed x equals 0, and when you solve it, you get the top of a hill or the bottom of a valley, right? Wasn't there a third possibility? It's called a horizontal point of inflection. Is there a third possibility for 3D surfaces? And the answer is yes, it's called a saddle point. I don't know how well I'm doing it. Can you imagine at that point, aren't you at the bottom of a shape that looks like that? But if you slice it the other way, aren't you at the top of a shape looking like that? See, if a person was on this surface, if you were here, wouldn't you have to walk uphill and then downhill if you moved in that direction? But if you moved in this direction, wouldn't you be moving downhill and then uphill? Can you see that they're totally different? One's a max and the other's a min. That's what a three-dimensional version of a point of inflection is like. Do you see how the world becomes quite different when you move into the real world of 3D? What do surfaces look like? So one of the uses for partial derivatives, and in particular when they are 0, is that it gives you some indication where one of these 3 things is likely to be happening. Any questions? Are we good? Okay, let's just get up to speed then. I've got a whole load of questions set up here. Don't know how many we'll get done, but I'll try and get as many as we can. I'm going to have to wait a minute because you're covering the thing I need to say. There we go. Right. Here's our first one. Nice function, polynomial. Find that guy, and then find this one. Right. That guy gets you nothing. Negative 3x squared plus 2y squared. Are you comfortable with that answer? Zooming through it quick. If you do a partial derivative with respect to y, nothing, nothing, and 4xy. If you want the partial derivative with respect to x at the point 2, negative 1, you're using this guy where x is 2 and y is negative 1. So that's negative 12 plus 2. I believe the answer would be negative 10. Are we comfortable with a nice polynomial? They're probably the easiest partial derivatives to calculate, agreed? X cubed and y's play well together. And this question here is going to need a lot more room than I gave it, so I'll rewrite. I want to find the partial derivative of that guy. Well, the first thing I'm going to do before I even think about doing partial derivatives is to rewrite it as a fractional power. Why am I doing that? Why? What advantage do I get in calling that cube root a third power?
Is it just easier to keep track of exponents when you're doing power rule?
Yeah, basically, don't you need a fraction to do the power rule? You need a power. Fraction is just happens to be what this one is. So let me do the partial derivative with respect to x. I typically write it this way. The book actually writes it with that. To me, isn't that kind of redundant? Do you really need to tell people the x, y bit? I mean, to me, that's how I normally write them, but you know, that's how the book does it, so we're fine. Would you agree this is a chain rule situation? So you multiply by the power, and you reduce the power by 1. And then you multiply by the derivative of what's inside with respect to x, and that just gets you what? 2x, right? All the other terms are 0. Now I'm going to make this, I don't know how pretty I'm going to make it, but it's going to be 2/3 x squared plus y squared plus 9 to negative 2/3. This is only a temporary part. I've got a lot more to do here. And I don't care what WebAssign takes. If WebAssign says, yeah, you're fine, that's WebAssign. That's not us. I want you to be good at math. I want you to be aware of style points. And aren't the rules for style points one of the major rules then? Make it look like the original. Right? There's lots of reasons why you want to do that, especially when you're evaluating it. It's right when x is 1 and y is 2. Don't you want to have cube roots? You don't want to have negative 2/3 powers, right? That would not be easy to get an exact value anymore. Now I'm going to call this guy 2x. I'm going to put the 3 on the bottom, and I'm going to take this negative power, and I'm going to bring it downstairs as 2/3. Are we comfortable with that? And then I'm going to take the 2/3 question.
No, I was just acknowledging that. That made sense.
Okay. Now what I'm now going to do is turn the 2/3, because it's thirds, it's a cube root. Because it's 2, it's x squared plus y squared plus 9 squared. Are we all happy with that? And that's style points. Right, that's what I mean when I say style points, right? Make it as pretty as it can. In this case, make it look like the original. In other cases, shouldn't you collect like terms, factor it, you know, whatever else, you know. But for the most part, you're probably just going to make it look like the original.
In this case, would it be good to distribute the square, like actually just square the polynomial there?
No, it would look much uglier. I would choose not to. Not that it would be wrong, but I just wouldn't. Now, I'm going to use a trick called symmetry. What symmetry allows us to do is to predict the other derivative, the other partial derivative, by recognizing that this function, right, the original, is symmetric. Remember, symmetric is you could switch the x's and y's and it's the same guy. Now, based on that, any volunteers for what this partial derivative with respect to y should be?
It'll be
Go for it.
2y over 3 times the cube root of parentheses y squared plus x squared plus 9 squared.
And what
So
you
it's
said
minus
is
squared.
correct, but I like alphabetical order. Not that that's important. Y squared plus x squared is exactly correct. Right, now, in this case here then, if you were being asked to find that fella, wouldn't it simply be 2 lots of 4, because remember that's the y value and that's the x, and on the bottom, 3 times the cube root of 1 squared plus 4 squared plus 9, brackets, all squared. And I'll keep going, but I might screw up here, so watch me. That's an 8, 3 times the cube root of 16, 17, 26 squared. I have no idea what 26 squared is, but that's what calculators are for. So the answer is 8 over 3 times the cube root is 676. Not the prettiest answer. Yes, question.
Shouldn't it be like let's see, like 37 squared?
Oh, I can't count. Let's check. 10, 1, 16, and 9. So that's 10 and 16. I'll still make it 26.
Oh wait,
And
sorry,
then you
that's 1
square
squared. Never mind.
Right.
I was reading it as 12. I was like,
oh well, yeah. My 2's a bit big for a pair. Now, okay, that's not particularly nice, but isn't it an exact value? Right? If I had left it as this guy up here, where is it? If I'd left it as like this version up here, you would be calculating, let's see if I can write it down the way it would look. It would look something like 2/3 x squared plus y squared plus 9 and negative 2/3. Now, if I'd plugged in 1 and 4 here, can you trust me that you would get 8/3, 600, well, it wouldn't even be 600, it would be 26 to the power of negative 2/3. Would you agree that's not a very pretty version of the exact value? Don't think I've made a great argument for why style points are necessary, but they are important. If you're going to communicate with other mathematicians, isn't it useful to have a rule about how all answers should be written? So style points is kind of the agreed version. You always make things in what I call style point form, right? So that my answer and your answer look the same because they are the same. But if people start doing, well, that's my answer. No, that's my answer. No, that's my answer. Can you see we now have 3 answers to the same question, and you have to figure out is your answer algebraically equivalent to the other 2 guys, right? And by the way, guys is sexless. I use guys when I talk about women and men, right? It's you guys, right? So there. I like that argument there. Have I convinced you? Here's my 3rd argument. I'll take points off you if you don't. Will that convince you that style points is a good idea? Okay, let's move on then. These are just practice questions. I don't have time to do all of them, so which one of these 2? Do you want 3 or 4? Which one do you want me to look at? 3 got us the job.
Example 4.
Too late. Somebody got you in 3. If I have time, I'll do a quick 4, but we'll see. Oh, I know what I'll do. I'll do one of each. So I'll do one of these 2, and then I'll do one of these 2. So I'll do this one, here with respect to x? Well, t cubed e to the negative 2x, when you differentiate it, is t cubed e to the negative 2x. Uh-oh, times something.
Times -2.
Yeah. Would you agree that it's easy to miss that -2? Yeah, if you're not careful. Let's try the other one. Z equals. Okay, what do you want, the x or the y this time? This
X.
one, x. Good choice. The y is a lot easier, agreed. So let's do the x. When you see two things multiply together and they both contain, in this case, the x, doesn't that make you think product rule?
Yeah, I was gonna say that looks like it's our good friend product rule.
It is. So I'm just going to write, you know, the generic version of what the product rule is. And remembering that these guys are actually, these two anyway, are partial derivatives. So if you differentiate, oh, I've got to make it clear here. This is the F and this whole package is the G. So you differentiate this guy, you get 2x and you leave that guy alone. So you get how much? Plus you leave this guy alone. And then you differentiate this with respect to x. And I am going to do a deliberate mistake here. Negative the sign of x cubed y squared. What's missing?
The chain rule, the 3xy squared. Oh, the 3x squared y squared.
You agree? Now, if I rewrite this just to complete the process, the first term came out pretty nicely. The next one has a negative, an x squared, some more x's going on, so it's negative. There's a 3, I believe there's an x to the 4 now. There's a y squared and a sine of x cubed y squared. And we are done. Are we cool with that one? I'd be generous here with style points. I'm happy with that as an answer. But if you were being a bit of a lawyer, technically what could I have done to make it even slightly nicer? But only slightly.
Factored out the x.
Yeah. Would you agree that it doesn't really bring much to the party? That's why I'm thinking it's not worth it. Right. I can imagine different world, right? You know, totally different question. Yeah, imagine that was the answer. Would you agree in this case, a common factor of 2x squared y squared does bring something to the party? Would you agree that helps the expression become a little bit tidier, right? So I wouldn't bother pulling out a common factor of 2, you know, if there was a 2 and a 4. I wouldn't be bothered in pulling out a common factor if it was only an x, right? It's not really worth it. But if there's a couple of common factors, you know, an xy squared here and an xy squared there, then I would do that because that I think is worth it, right? It does do something. I don't know if I've said this. I probably have, but in case I haven't, remember to say your last name. And that is us. I'm going to hang about for a few moments if you have any questions. Otherwise, I will see you tomorrow.